Another way to solve this question would be to use the superposition principle. Remember, in the second experiment that we built in this lab, here we had 5 volts, and here we had 15 volts, and this is 15 volts. So the way I would go about solving this using the superposition principle is that let's start by shorting the 15 volt. So if I shorted, the circuit is going to look something like this. And this is going to be the 5 volt. This is going to be my V out, and this is R1, R2, and R3. Now I'm going to find V out. So to find V out, I'm going to calculate the equivalent resistance of these two. So you see that these two resistors, R3 and R2, are now in parallel. So I'm going to calculate the equivalent resistance. And the equivalent resistance in here is simply going to be 6200 multiplied by 4700 divided by 6200 plus 4700, and this would give us 2673 ohms. So this is the parallel equivalent of these two. And now I'm going to use the voltage divider rule. Let me just make it a bit simpler for you. So this is R1. Now we took the parallel equivalent, so we have this resistor. So now here we have R1, this is R1, and this resistor's value is going to be the equivalent that we just calculated. And across it, we will have V out. So now I'm looking for V out. Now I'm going to use the voltage divider rule. So I'm going to take 2673 divided by 2673 plus R1, which is 3900, and I will multiply that by Vs, which is in this case going to be 5 volts. So this will give me V out equals to 2.03. Let me just write everything that I did. So I took 2673 divided by 2673 plus 3900, which is R1 in here, multiplied by 5 volts, and that gave me 2.03 volts. Now this is the contribution of the 5 volt to V out. Now I'm going to increase the 5 volt to 6 volt and see what contribution does it give. So I'm going to multiply this same number here by 6 volt. So I'm going to take that and multiply by 6, and we get 2.43 volts. Now I'm going to take the difference in the voltage. I'm going to call it delta V. I'm going to take this value minus this value, and we see that it's going to be 0.4 volts. Now I'm going to do the same thing but with the 15 volt supply. So let me just free up some space in here. I'm going to short this one. Well, it's all gone. Okay. So I'm going to short the VN1. Then I'm going to short the 5 volt. So the circuit would look like this. And this is the 15 volt. So this is R1, this is R3, and this is R2, and this is plus minus VO. And this is the 15 volt. Now I'm going to do the same thing. I'm going to find the equivalent resistance of R1 and R2. We can see these two resistors are in parallel. So to find their equivalent resistance, we would simply take 6200 multiplied by 3900 divided by 6200 plus 3900, and that would give us 2394. So this is the equivalent resistance of R1 and R2. Now the circuit will, I'm going to use the voltage divider rule. So I will have, this is the R equivalent that I just found, this is R3, and this is the minus 15 volts. Now this is plus minus VO, and this is the 15 volts. Now I'm going to use the voltage divider rule to calculate VO, and to do that I am simply going to take this value 2394 divided by 2394 plus R3, which is going to be 4700, and multiplied by minus 15, remember, because this source is flipped. And this would give us, let's see, 2394 divided by 2394 plus 4700 times minus 15. This would give me minus 5.06. This is minus 5.06 volts. This is volts. I don't have enough space to write it. Now, this is the contribution of the 15 volt power supply to V out. Now, what I'm going to do is that I'm going to increase this value. So I increase this value here by 1 volt. It became 6 volts. Now I'm going to increase this value here by 1 volt. So we would get 14 or minus 14 volts. So I'm going to multiply the same number by minus 14, and we would get minus 4.72 volts. Now I'm going to take minus 4.72 minus this value, so it's going to be minus 5.06, and delta V will come out to be 0.33 volts. Now you see the delta V in here is smaller than the delta V in here, and this means that V in 1 will have a bigger effect on the output voltage.